Hello, college biology. In our last video, we introduced carbohydrates, talked about their composition and their polarity. We introduced monosaccharides, talked about their forms and that they could isomerize between linear and ringed form. We talked a little about some examples of monosaccharides, and now we're going to go to a new category, disaccharides, where monosaccharides are single sugars, disaccharides are two sugars. And so let's take a look at what that looks like. Here we have two glucose molecules. These are both monosaccharides, and they are going to undergo a condensation reaction. And when they do, they're going to link to each other to create a disaccharide. This is a two-member sugar. So there's two sugars in a disaccharide. It's two monosaccharides linked together. And this one is maltose. This is a malt sugar. Now, the thing is that if you have different sugars, different monosaccharides, and you link them together in different ways, you can make different things. So a second example of a disaccharide would take a glucose and a fructose and bind them together with a condensation reaction, and then we will create sucrose. Sucrose is same thing as table sugar. So when you add sugar to your Kool-Aid, you are adding sucrose. You are adding a glucose molecule and a fructose molecule bound together, and then you get trillions and trillions of those, and you put them in your Kool-Aid, and it's delicious. Or maybe it's tea, or whatever. I don't know. But sucrose is table sugar. So we know that fructose is made in fruits, but when you bite into that apple, there's going to be some sucrose in there too, because the fructose is going to be made bound to glucose, and it's going to give it that sweet flavor that we like in our things that are foods, because they're delicious. So that's it. That's all that I have for disaccharides. They are two monosaccharides linked together, and our examples are that two glucose can be linked to make maltose, and a glucose and fructose can be linked to make sucrose, which is our table sugar. So let's go to polysaccharides. Now, polysaccharide means many sugars. So we have one sugar, two sugar, many sugar. That's how the words break down. Monosaccharide, disaccharide, polysaccharide. So how does that work? Well, what the polysaccharide is will depend on what is being linked together and how they're being linked together. So polysaccharides are polymers. And we kind of hinted at monomers in our monosaccharide video, but now it's time to really bring those together. A monomer is a molecule that is one link in a repeating chain that makes a long molecular chain. One repeating unit in a long molecular chain. That's the monomer. The polymer is the long molecular chain. So when we say that polysaccharides are polymers, we mean they're made of repeating units of the monomers. And monosaccharides are the monomers. So you take a bunch of monosaccharides, link them together, you got yourself a polysaccharide. So what does that look like? Well, let's take a look here. As you can see, we can link glucose together right here, and it's just repeating glucose over and over and over again, and that's going to give us the polysaccharide starch. Or we can take the same molecule, glucose, and link them together, except we flip them over, and so we alternate the glucose, and that will give us cellulose. So we're going to start with cellulose. Cellulose is a long chain of thousands of alternating glucose. So it's made of glucose, and there are thousands flipped, alternatingly flip, 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 flip. Now, this is a cellulose molecule, and it's kind of hard to see what's going on here, but this is one glucose, this is another glucose, they're flipped, and they're linked together, and then that keeps going. But what happens with cellulose is that strands of cellulose will form hydrogen bonds to each other. So this is one row of cellulose, this is another row of cellulose, and there are hydrogen bonds together. And another row of cellulose, because they're polar, they'll make hydrogen bonds with each other. And another row of cellulose, and they'll make hydrogen bonds. And what that will do is that will form a very sturdy structure that has some structural integrity. And that structure will become a cell wall. This is another example of that molecule where you have the cellulose, the flipped glucose molecules in a long chain, because they're a polymer, that will form hydrogen bonds with each other, and then you'll have this sheet of cellulose that will have this sturdy connection, because not only are they have hard connections connecting each glucose to each other, but they have hydrogen bonds connecting each separate thread of the of the cellulose to each other to give them a sturdy structure. Now, that cellulose we can't digest it. So this cell wall material that is made from sugar, from glucose, we can't get energy out of it. We can't cut that up and get glucose out of it and get energy from the glucose. We can't do it. Cows can. Lots of insects can. There are a lot of things that can digest cellulose for energy, but we can't. So cellulose is a structural material plants use to build the cell wall, and it's digested by some organisms for energy, but not humans. We have lots more to say about polysaccharides, but this video is getting long, so we're going to review what we have. Our second division of carbohydrates were disaccharides, which means two sugars, and those are two monosaccharides linked together. And our examples of those are sucrose, which is a glucose monosaccharide and a fructose monosaccharide bound together, and that's the same thing as table sugar, and maltose, which is two glucose molecules linked together, which is the same thing as a malt sugar. Now, polysaccharides are mini sugars, and they are polymers, which are long chains of repeating monomers, and the monomers are monosaccharides. And our first example was cellulose, which is thousands of alternatingly flipped glucose, and those strands fold back to make parallel lines which form hydrogen bonds with each other. That builds a sturdy structure that is used to build cell walls, and humans cannot digest cellulose to glucose to get energy, but other organisms can. So that is all for now. We'll talk more about polysaccharides in the next video. I hope this helps. Struggle well.